Okay, Assalamualaikum, a very good evening. So, my name is Azzam Iswaimi. Matric number 199145.
And I'm Hadi with my metric number 198722.
And my name is Hashim Arabi, and my metric number is 198642.
And my name is Muaz bin Ibrahim, my metric number 198829. And today we are going to present about farming in saline soil.
Okay, as we have mentioned about the saline soil, so I'm just gonna give you what is the definition of the saline soil itself. So next. So a little bit about introduction. What is saline soil? So it is actually a soil that contains the salt into it, one of its components. So one of the process that is quite familiar with this saline soil is actually salination. So what is salination? It's a process of increasing the salt content. So we can see that one of the causes we can break down into two parts, which is the first one going to be natural, and the second one going to be the artificial. So for the natural causes of this salination, it's going to be from the mineral withering, and also from the gradual withdrawal of the oceans. As we know, oceans are usually saline in pH. And also, not to mention about the artificial, which one gonna be irrigation and also the road salt. So next. So you have known about the definition of the saline salt. So let's go down into the characteristic about the saline salt. So one of it is gonna be the contains neutral soluble salts of chloride, calcium, magnesium, and sulfates as one of its component. And the second one is going to be electrical conductivity of saturated extract of salt. It's actually more than 4 ds per meter. And for the ESP, it's less than 15. And as been mentioned about the pH, it's less than 8.5. And for the physical condition, it's good. And also water can pass through them. And last but not least, we have white crust on salt on their surface.
Okay, moving on to the effects of saline soil on crops. So there are many effects of the usage of saline soil on crops, but I will narrow it down to three main things. So the first one, the usage of saline soil will affect the plant growth and nutrition. So the salt will affect the plant growth due to increasing soil osmotic pressure, which will interfere with plant nutrition. High salt concentration in soil also reduces ability of plants to acquire water, which is referred to as osmotic or water deficit effect of salinity. Damage occurs when the concentration is high enough, and then the osmotic effect of salinity induces metabolic changes in the plant, identical to those caused by water stress induced or wilting. Next, moving on to the second effect, which is the saline soil will affect photosynthesis. So salinity will affect photosynthesis by decreasing the carbon dioxide availability as a result of diffusion limitations and a reduction of the contents of photosynthetic pigments. Salinity will lower the total photosynthetic capacity of plant through decreased leaf growth and inhibited photosynthesis, which will limit its ability to grow. Salt accumulation in the root zone will cause the development of osmotic stress and will disrupt the cell ion homeostasis by inducing both inhibition in uptake of essential elements such as potassium, calcium, sodium, and also accumulation of the sodium chloride. So accumulation of these injurious ions will inhibit photosynthesis and protein synthesis, which will inactivate enzymes and damage the chloroplast and other organelles. Next, so saline soil will also decreases the marketable yield. So salt stress decreases the marketable yield due to decreased productivity and increased unremarkable yield of roots, tubers, and leaves without commercial value. So irrigation of saline water has been shown to enhance the appearance of blossom and rot in tomato, pepper fruits, and eggplants, a nutritional disorder related to calcium deficiency. However, salinity has some favorable effects on the quality of edible part of vegetable crops. So in general, salt stress, with the exception of visual appearance, which is size, shape, and absence of defects, improves the quality of edible part of vegetable crops.
So next I will be presenting about salinity control and its method. So the first thing first, we need to know what is salinity control, soil salinity. So what is soil salinity? Soil salinity is the salt concentration in the water extracted from a saturated soil called a saturation extract. And if this water contains less than 3 grams of salt per liter, then the soil is said to be non-saline. And if the salt concentration of the saturation extract contains more than 4 grams per liter of salt, then the soil is said to be highly saline. Then next is soil salinity control. So soil salinity control relates to the controlling the problem of soil salinity and its reclaiming salinized agricultural land. Reclaiming here meaning that we want to claim back the salinized agricultural land, which will be then turned into a non-saline soil, which will help us to produce more crop and yields a higher crops productions. So why salinity control is important in agriculture? So the first thing first is to prevent soil degradation by salination. Salination is dangerous and it adds the salinity of the soil, which can harm the crops. And next is to reclaim already salt or saline soil. So next, then the amount of crop yield reduction, which the crop yield depends on the salt content of the soil. So salinity control is important to make sure that the amount of crop yield is higher. So for soil improvement, rehabilitation, remediation, recuperation, and amelioration. So next is to improve crop growth by removing excess salts from the root zone. Crop growth is very important to make sure that the crop is high in quality. So we need to remove the excess salt from the root zone by doing methods in salinity control. Next, so methods used in salinity control, we have 3. So the first one is the scraping, which are the removing of the salt that have accumulated on the soil surface by mechanical means by using a machine. And scraping method has had only a limited success, although many farmers have resorted to this procedure. Why? Because it just removes the salt on the superficial surface, so it's not that effective. Then although this method might temporarily improve crop growth, the ultimate disposal salt still poses a major problem. So disposal of salt that has been drained from the soil is a major problem of this scraping method. So the second method is by flushing, which is the washing away of the surface accumulated salt by flushing water over the surface. It's sometimes used to desalinize soils which having a surface salt crust. Because the amount of salt that can be flushed from a soil is rather small, this method does not have much practical significance. Same as the scraping method, so this method is not as effective in order to control the salinity of soil. So the last one, leaching, is the best and the most effective method. Salt leaching, or basically saline soil leaching, is the removal of excess salt, all not on the superficial only, from arable and subsurface soil horizon by flushing water. It's same as the flushing, but then it involves the overall soil, not just the surface of the soil. So by far the most effective procedure by removing salt from the root zone of soils. So meaning that the salt is drained from its root. And leaching rates, water quantity required for dissolution and dispersion of salt from saline soil are determined depending on salinization degree, composition of salts, whether the salt contains sulfate, chloride, and carbonates, permeability, meaning that the substance that can go into and out of the soil, and grounded water level. So leaching may reduce salinity levels in the absence of artificial drains. So we need a artificial drainage, to maintain its salinity levels when there is sufficient natural drainage. Next, leaching during summer month is less effective. Why? Because large quantity of water are lost by evaporation. We don't want the water to be lost by the hot environment. Effectiveness of leaching depends on the physical properties of soil and salinity degree. Example, ratio of salts of calcium and sodium ions in the soils. Leaching soils is a radical improvement of saline and alkaline soils. Example of ratio soluble salts of calcium and sodium ion in the soils. So what can I conclude here is that the leaching is the best and most effective method, as it drain the salts not from just the surface but from the root zone also. So that's for the method and salinity control.
So I will continue about the disadvantages of farming in saline soil. So generally, farming in saline soil cannot decrease the agricultural production and low economic returns and soil erosion. And affect plants grossly, it will affect the germination, vegetative growth, and reproduction development. And formally, it will affect the ion toxicity and cause the osmotic stress, nutrient deficiency, and oxidative stress. And thus, this will limit the water uptake. Okay? And for example, some ions such as sodium, chlorine, boron have a specific toxic effect on plants. Excessive accumulation of sodium, as an example, can rapidly lead to cell death because of the osmotic concentration due to hypertonic effect. And the high salt levels in the soil can upset the nutrient balance in plant or interfere with the uptake of some nutrients, because some ions are also needed for plants to growth. And reduction in leaf area, chlorophyll content, and stromatal conductance. Next. And next is the use of microbes. Okay. When speaking about microbes, the terms PGPB is important. That is a plant growth promoting bacteria. Okay. And under the PGPB, we have PGPR, plant growth promoting rhizobacteria, which colonize the rhizosphere or endorhizosphere species of plants to promote the growth on direct or indirect mechanism. Okay. This can enhance the tolerance to abiotic stress by reducing the plant pathogens or facilitate the nutrient uptake through phytohormone production like cytokinin, auxin or gibberellins, by enzymatic lowering of plant ethylene levels or production of siderospore. And next, they can isolate the Bacillus polymixa, Mycobacterium flake, and Pseudomonas alcaligens to make effect on to tolerate the high temperatures and salt concentrations. And that's all from us. Thank you very much.